Thank you for having me. As far as myself, I'm chair of the requirement working group, and I've been either a co-chair or chair for the last 25 years. Before that, I spent 22 years in the United States Air Force. Most of that was supporting the space program. I did a lot of work with NASA, and I was in the launch team for the very first space shuttle launch. And then I moved to Houston, and I was involved in on-orbit operations for several of the space shuttles. And then when I retired from the Air Force, I supported DoD missions on the space shuttle. And then I worked in the astronaut office for about 5 years, helping plan for how they are working on the International Space Station. And then in 2000, I left that world and started focusing on requirements and teaching requirements seminars for across multiple domains. And that whole time, I've been a major part of INCOSE and the requirements working group. We published the Needs and Requirements Manual. A lot of the figures that I'm going to show came from that. In the Needs and Requirements Manual, I do mention sustainability along with safety, security, and resilience as kind of the four considerations that people should be taking when they're developing engineered systems. Getting on with this, defining needs and requirements, sustainable systems. I first gave this at a symposium in Spain in 2023, and I gave it again to the Chicagoland and COSI chapter. And then I've updated it for today, adding some more recent developments. In doing this, I did a lot of research. So part of developing this was education myself concerning sustainability and what it really means and the impacts for that. Some goals and objectives for the webinar: understanding sustainability in terms of the INCOSE Vision 2035. All the working groups need to try to achieve INCOSE Vision 2035, including the goals and objectives for sustainability. And then sustainability can have different meanings and depending on the context. So talk about what's meant by sustainability from a system engineering perspective. Understand why sustainability must be clearly defined in terms of the enterprise, a specific system of interest in their external environment. Understand why sustainability must be addressed in the beginning of a project. It's got to be what they call baked in to the organization and the products. It's not something you address later. Learn what activities are needed that result in the definition of lifecycle concepts to address the project goals and objectives concerning sustainability. Understand the need to define the capabilities needed to achieve organizational sustainability goals and objectives. Understand the need to communicate those capabilities within a well-formed integrated set of needs that define the scope of the project in terms of sustainability, and for which the design input requirements concerning sustainability will be transformed and against which the system will be validated against the integrated set of needs and verified against the design input requirements. And then finally, there will be a slide on the practical considerations concerning sustainability. In COSI 2035, sustainability was a big part of that. They want to architect balanced solutions that satisfy diverse stakeholder needs for capability, dependability, sustainability, social acceptability, and ease of use. And they talked about global megatrends that shape the systems of the future and advance the technological capabilities and societal appetite for applying these technologies in a responsible, sustainable manner while transitioning away from fossil fuel-based energy. A key thing is sustainability ethics. Sustainability will become a key attribute of the enterprise culture and products. I can't emphasize this anymore. Sustainability starts at the top. And if that's not part of the overall ethics in the strategic planning of an enterprise, it's not really going to happen. An enterprise will need to develop a positive ethical identity to attract and retain customers as well as employees. The systems of the future will become smarter, self-organized, sustainable, resource efficient, robust, safe, but trusted in order to meet stakeholder demands and expectations. Priorities will be placed on systems that are more efficient at resource utilization, responsible waste disposal, though enterprises will continue to struggle with business and consumer pressures to increase consumption versus environmental prerogatives to reduce waste. Society is going to place a greater importance on reuse, giving rise to circular economies. The global fossil fuel-based energy economy will be transformed into one based on clean, renewable resources. The growing stakeholder expectations for sustainability. Stakeholders are going to demand that systems and services are environmentally sustainable, such as minimizing waste, undesirable impacts of climate change. Sustainability as a system or characteristic could be stressed, as well as sustainability ethic of the responsible enterprises and more efficient resource utilization, recycling, reuse, responsible waste disposal. Social acceptability, minimize the impact on society and the environment, transition away from fossil fuel-based energy, minimize the carbon footprint, and use clean and renewable sources, apply technologies in a responsible manner, and maintain sustainable and affordable systems. And affordability has got to be considered. This is a vision. It's kind of an ideal state, a vision of the world in terms of sustainability, but there's a lot of practical considerations that sometimes achieving this vision is difficult. And I'll talk about some of those as we go through this presentation. One thing is define what sustainability is. The ability to be maintained at a certain rate or level is one. So sustainability from a company could be, can we stay in business? And what do we need to do to stay in business? So that can be a concern. The ability to maintain or support a process continuously over time. This would apply like to supply chains. Sustainability is a societal goal that relates to the ability of people to satisfy coexist Earth over a long time. Sustainability is commonly described as having three dimensions or pillars: environmental, economic, and social. So you have this picture about people, planet, and profit. That's part of the economy. It's interesting, just this morning, Richard Beasley from the UK had a post about sustainability on LinkedIn, and he included this figure. I just pulled that off there this morning when I was preparing for this. We have to think about all three. You really can't think of one without the other. So what is sustainability again? INCOSE focuses on environmental sustainability. Everything we need for survival and well-being depends on either directly or indirectly on our natural environment. To pursue sustainability is to create and maintain the conditions under which humans and nature can exist in a productive harmony to support present and future generations. Sustainable development requires an integrated approach that takes into consideration environmental concerns along with economic development. When I talk about myself, I didn't talk about my education. I have a bachelor's degree in electrical engineering, but I have a master's degree in computer information systems. And I also have a master's degree in environmental management. My interest in environment is really great. I volunteered for 30 years at a nature center as part of that. But also, I worked on a master's degree called Studies of the Future. And one of the considerations is the future generations, the difference between present needs and future needs, especially from a politics standpoint, and then the economic drivers. All of these have to be considered when we're talking about sustainability, and they can pose some significant challenges. And I'll give you some examples of that. So then we get into systems engineering and sustainable engineering. And so sustainability engineering is an approach that supports the circular economy over its life, process of designing or operating systems such that they use energy resources sustainably. In other words, at a rate that does not compromise the natural environment or ability of future generations. Reduce a product's environmental effects at every stage of its life cycle, from conception, deployment, prototyping, commercialization, recycling, disposal. The practice of designing products and processes that drive material and energy efficiencies to minimize their environmental impact while cutting costs and improving the bottom line. So again, we have cutting costs, improving the bottom line, really profitability. Organizations are going to be worried about their return on investment when they're engineering systems. This is going to be something that we always have to consider when we're engineering systems. Manufacturers can minimize waste while maximizing the value they deliver. Environmental ecology. When I get my master's degree, where the waste of one business was an input to another business, and then their waste was an input to another business. And so the cooperation of multiple businesses can help reduce waste or eliminate waste, if you will. The process of using resources in a way that does not compromise the environment nor deplete materials for future generations basically means finding ways to live more sustainably. In the INCOSE System Engineering Handbook version 5, they have a section on product sustainability, disposability, and they talk about the need to design for sustainability when we're doing engineered systems. So we need to always consider environmental and social aspects as key elements in the product design to reduce harmful impacts of the product throughout its life cycle, promote recycling and materials reuse, design components toward the circular economy, sharing, reusing, repairing, recycling existing products and materials as much as possible, expanding the life of products, minimizing waste and pollution, and creating a closed loop system. Perform environmental impact analysis across all lifecycle stages to assess potential harmful effects of the production, use, disposal of the proposed system. Considerations, materials used, scrap waste from production process, operation of the system, replacement parts, consumables, packaging, disposal. Again, this all has to be considered by the organization as part of their core values. And then do a disposal analysis, maximize the economic value of residual system elements after useful life, minimize the amount of waste of materials sent to landfills or incinerated, design for disassembly to avoid destructive separation of components, such that material can be reused in future generation products, remanufacturing, refurbishment, or recycling processes, design for decomposting or biodegradation. A lot of considerations. Again, this has to be part of the DNA of the organization to develop products sustainably and disposably. And that's kind of a challenge for some. And so when we talk about sustainability, how do we measure this? And this is the first step when it comes to defining needs and requirements for our systems, is how are we going to measure this? We can have measures concerning recycling, reuse, increased use of clean energy versus fossil fuel based, increased use of renewable resources, increased product life, increased efficient use of resources, materials, and energy. We can reduce the need for and use of non-renewable resources, reduce waste put in landfills, reduction of hazardous waste, reduction of harmful emissions, reduction of carbon footprint, reduction of costs associated with sustainability. When you talk about sustainable cities, one thing that comes in is sustainable buildings. And so there are certain performance measures for buildings, the energy use intensity, the BTUs per square foot per year, water use intensity, gallons per square foot per year, carbon intensity, and waste diversion rate. These all can be measures when coming up with a design for buildings, and you could scale this up from cities as well. And then we have to think about what are other measures and metrics that could be used when we're doing this. If we don't have measures, we can't set goals, we can't set objectives for sustainability within our organization or within our products. So it's extremely important that we think about this. Later on, I'll talk about a set of needs that we define that address these measures. Sustainability considerations, a key thing that we always focus on is environment, but also we have to think about the sustainability of the enterprise. Is viability sustained over time? And then we have to consider the engineered systems. Are they sustainable in terms of performance, maintenance, resources, the supply chain? And one thing that we find is that it may be to address sustainability of our enterprise or our engineered systems, we may have to sacrifice some sustainability from an environmental standpoint. I'll give a prime example of that in a minute. All three are interrelated, depend on each other, must be considered as an integrated system, and systems thinking principles must be considered. The behavior of a system is a function of the interaction of its parts, interaction of the system with external systems, and operating environment. Some examples are illustrative. We can always go to natural systems from a sustainability standpoint. Our forests, oceans, rivers, lakes, deserts, mountains, atmosphere. These ecosystems are part of the environment, dependent on the environment, contributes to the health of the environment, uses renewable natural resources, waste is biodegradable, is recycled, sustainable. They refer to a natural system as in being a climax state when the inputs and outputs are in balance, and their resilient ability to return to a climax state after acted upon by a natural disaster, human activities, engineered systems. And then we have engineered systems, and that's our focus from a system engineering standpoint. And there's engineered systems that operate within our biosphere, and I'll give some examples of some engineered systems that operate outside our biosphere for comparison. The engineered systems that are operating within the biosphere are not separate, but they're part of the environment, dependent on the environment, use both non-renewable and renewable natural resources. They often create waste, can impact the environment. They're also impacted by the environment. But we need to address sustainability. We need to manage sustainability so that we have efficient, sustainable use of resources, minimize impacts to the natural environment, depletion of natural resources, pollution, waste management. So some examples. So sustainable cities, and this is a vision for sustainable cities. If you're going to build a city from scratch, this is something definitely that you'd want to move toward this vision. So we have a sustainable city that's an urban center that makes rational use of natural and technological resources while ensuring adequate habitability without compromising future generations. Sustainable cities prioritize the preservation of the natural world alongside the economic, social, and physical health and wellness of the city's inhabitants. Sustainable cities aim to change the way they operate for the benefit of future generations, encouraging that they do not put a strain on resources which will cause such resources to vanish before future generations have an opportunity to benefit from them. And sustainable cities are designed with environmental concerns in mind and committed to achieving green sustainability, social sustainability, economic sustainability, reduce environmental impacts through its activities, and promote sustainable consumption production patterns in accordance with its own territorial, geographical, social, economic, and cultural considerations. And then, just like natural systems, you'd expect them to be resilient to the impacts of climate change, reducing the vulnerabilities of its population. Now, I said this is a vision, kind of an ideal state, but we have to look at the realities. The realities is, can a city, especially existing cities, be truly sustainable? They're not closed systems, they're open systems, heavily dependent on external inputs, food, energy, resources, water, air. There's the environmental impacts, the amount of waste, pollution, impact on the local climate. I live here in Houston, a very big footprint, lots of concrete, lots of highways, lots of buildings, and it creates its own climate. We have what's called the heat island. You can see weather systems coming through, and they sometimes they split and go around Houston because Houston's impacting the actual climate itself. Then we have increasing threats, sea rise. There's so many cities right now that we have that are close to the coast. Sea rise is going to cause flooding, increased hurricane, especially the size and force of hurricanes, number of tornadoes, drought, fires, depletion of aquifers and other sources of water are all problems that impact the actual sustainability of a city. And then we have the political will towards sustainability. A lot of the politicians focus more on the present than the future. They don't want to spend the money, address the issues 10 years from now. They're worried about today. To get our goals, we need to update our building codes from a sustainability standpoint. A lot of places, the building codes don't support sustainability. So that's the challenge we have. A lot of our existing systems have aging infrastructures, especially like in Europe. You have cities that are hundreds of years old, and the infrastructures need updating from a sustainability standpoint, and then inadequate infrastructures. Just this morning, I read a headline said the population boom in Houston suburbs is straining water systems. Can they keep the taps running? And a quote from this one guy, I have some very serious concerns about water quantity, said Chris Bower. Development has outpaced the infrastructure. We're producing water and producing fast. We just can't keep up with the development. So that's another aspect of sustainability is growth, a big challenge. And then from a technology standpoint, something that's becoming more visible in the news is from a technology standpoint, especially AI and data centers. High energy demand, training running large AI models consumes 7 to 8 times more energy than typical computing workloads. Global data center electricity use has reached 460 terawatts in 2022, and it's increasing almost exponentially. So that's a big challenge around the world. Carbon emissions, if powered by fossil fuels, this energy use translates into significant CO2 outputs contributing to climate change. Water consumption, data centers use vast amounts of water for cooling, in some cases as much as a large neighborhood, straining local water supplies. Electronic waste, frequent hardware upgrades to high performance GPUs and servers generate e-waste contain hazardous materials like lead and mercury. And resource extraction, manufacturing AI chips requires rare earth elements and critical materials often mined in environmentally damaging ways. And so this is a really big challenge. And you'd think that countries would be addressing this in their laws. But sadly, in the United States, we just had a presidential proclamation signed, winning the race, America's AI Action, and they're waiving or streamlining environmental regulations for data centers, semiconductor plants, and related power infrastructure, deregulation under the Clean Water Act, fast-tracking siting and new rules for centralized control over wind and solar projects in federal lands. Everything in this thing is anti-sustainability. It's an issue that it's sad, but it really takes away from meeting INCOSE's vision for sustainability. Going outside our biosphere, we have like the International Space Station, the Chinese Space Station. They're in low Earth orbit. Solar energy is their only natural resource. They're very dependent on resupply from Earth for fuel, the crew, food, parts, water, air. They cannot sustain orbit without periodic reboost. Limited resource recycling, water and O2 is limited. They do their best, but there is leakage and waste. So there has to be resupplied from the ground. Waste disposal, there's a lot of waste that is created, and right now they don't have a way to really dispose of it. They don't want to throw it out, cause space debris. So it has to be brought home to the earth, either so it can burn up in the atmosphere or return to the surface and be either reused or put into the landfills. They're susceptible to poor waste management from other orbiting systems, orbital debris, which is always a hazard, and susceptible to the space environment, microgravity, micrometeorites, radiation, sunspots, and so on. So really, these are not sustainable by design. There can be a lot of work for reuse of water, but space station really is a very open system. It cannot sustain human life without frequent external support, resources, waste disposal. You can move on to say we're going to establish a moon base further from Earth, increase time, days, expense for construction, resupply. A combination of solar and nuclear energy can be used, depending on resupply, fuel, earth, food, parts, water, air. It'd be a long time before they could grow enough food to feed their population. There is some possibility of using in situ resources on the lunar surface to create water, oxygen from the regolith. It's a high energy processes, but there is a possibility. And then reuse, additive manufacturing possibilities for reuse, which would reduce waste. So that's got to be an issue. When you go off the Earth, waste is a big thing because the extreme high cost of resupply, anything that has to be transported to the moon base costs a lot of money. So any way you can minimize that, you want to do that. In the design of a moon base, minimizing waste has to be a big consideration. Recycling reuse must be maximized. And however you can recycle water, oxygen, and building materials. So sustainability of a moon base has to be a number one design consideration. The environment's very negative, no atmosphere, extreme temperature swings, extended day-night cycles, and the low gravity, increased radiation shielding is a necessity. You have to cover everything with regolith or live in lava tubes. The natural environment's harmful to humans. Again, a major concern is sustainability of the engineering systems rather than the natural environment. It's a little bit different on Earth. Our focus is on the natural environment. When you leave Earth, the focus has got to be sustainability of the engineering systems. And so it must be a primary consideration for our architectures and design. And the question is, can a moon base ever be truly sustainable given its dependence on resupply? And then we go further out in a Mars colony. Now, that's a very long distance from Earth, so time to get there is measured in months, extremely expensive for its construction, resupply, transporting all those materials. They can be powered by a combination of solar and nuclear energy. That distance from the Earth's solar is not near as efficient. They've had a lot of problems with dust covering the solar panels, cutting down the efficiency. Dependent on resupply from Earth for the foreseeable future, but that's in 2-year cycles, which are problematic. On Mars, there is increased access to in situ resources from the surface, possibly water. Carbon dioxide can be used to make fuel. We can use the soil, the possible natural resources, but the soil itself is hazardous with perchlorites, so that's a challenge. Atmosphere to use fuel methane when supplemented with a source of hydrogen. Recycling reuse has to be maximized, waste minimized. It requires sustainable capability to produce food, air, water, maintain systems, limit atmosphere, extreme temperature swings again, hazardous environment, 1/3 the gravity, need for increased radiation shielding. Again, they're going to have to cover everything with regolith or live in lava tubes underground. And then there's questionable sustainability from a human reproductive perspective. The low gravity, the radiation impacts the reproductive systems and fetus development. You really can't have a sustainable colony on Mars if the humans inhabiting the colony can't reproduce. So that's a big question that we have to worry about. Again, the major concern is sustainability of the engineered systems rather than the natural environment. However, there are planetary protection guidelines that must be considered. So there is some hooks into the natural environment if we adhere to those planetary protection guidelines. So again, it must be a primary consideration for our architects and design. Again, the big question, can a Mars colony ever be sustainable given existing constraints? These examples illustrate why sustainability needs to be considered at the very beginning when we're developing engineered systems, whether they're engineered systems to meet our goals, our vision for on Earth, or engineered systems for humanity's expansion into space. So, sustainability considerations. Looking at your system, your organization, what sustainability considerations can you define for your system and products? What sustainability measures can you define and to assess your sustainability goals? What processes, procedures, requirements can you define to help meet your sustainability goals for systems, products you produce? Organizational design controls for systems and products. So again, up front, the enterprise has to address sustainability from the very beginning. And so one of the figures that we have in the needs and requirements manual shows the different levels. We have an organizational level view, strategic view, operational view, system, subsystem, system elements. Organizations must include the concept of sustainability in their core set of values and policies. The strategic business plan at the very top has to address sustainability. From a product perspective, the enterprise must define processes, procedures, and work instructions concerning sustainability across the life cycle. When you look at life cycle concepts, we have to look across all the life cycle and say, what do we need to do to address sustainability for each life cycle stage that's defined? And for individual products, sustainability must be included in the product mission statement, goals, objectives, life cycle concepts, integrated set of needs, and resulting design input requirements. An example of that from an organization, Apple came out with this about massive battery sustainability, upgrade all its devices. And so they have a corporate policy to expand the use of recycled materials across all Apple products, make every Apple product carbon neutral. They're also tackling waste, so tackling plastic and so it only has 4% plastic, and this reduces hydrocarbon usage as well. New printing methods, robust product trade-in refurbishment program, part of the circular economy, future of the planet more in the public conscience than ever before. They want to address that social demand that was in the INCOSE Vision from a sustainability standpoint. And they have 250 of Apple suppliers committed to transitioning to 100% renewable electricity for Apple production. My question is what about the other sustainability measures of the suppliers? To be truly sustainable for Apple's products, all their suppliers must share the same organizational goals for sustainability. Again, the focus on environment, so the supply chain reuse and waste minimization. We talked about space stations. Again, or yesterday on a post on LinkedIn, Axiom Space talked about incorporating lessons learned from the International Space Station equipment failures and malfunctions, and they have pointed their focus toward ease of maintenance and future upgrades. With the vertical integration in-house design manufacturing, they have optimal control of the space station hardware. They're going to design systems to be maintainable, upgradable, repairable on orbit with as little need for ground resupply as possible. Even though they didn't use the word sustainability, sustainability is going to be aided by decreasing the need for ground supply. While this is a good step towards sustainability, they also need to make sustainability a key goal for not only resupply, but orbital maintenance, reuse, and waste minimization as well. So in the context of the focus of sustainability is an ability to sustain on-orbit operations. It's not an environmental thing as much as sustain on-orbit operations of the space station. I mentioned earlier about customer supplier common goals. This is another figure in the needs and requirements manual. The customer organization and the supplier organizations need to be in sync concerning sustainability and must be consistent. So when a customer is issuing contracts or selecting suppliers, sustainability must be one of the considerations when they're selecting a supplier and when they're issuing statements of work concerning procuring of parts and materials from suppliers. And so this is an area that, from a procurement standpoint, is not currently addressed, but it's something that must be addressed if you're going to meet your sustainability goals as an organization. And so sustainability must be addressed from the beginning of the project. On the left is all the different kind of things that we define from the beginning of the project, our problem opportunity, our measures. So the measures have to include our sustainability measures, stakeholder needs and requirements, real world expectations for sustainability, use cases and how we're going to maintain operations sustainably and develop ops cons, con ops for that. Our higher level needs and requirements concerning sustainability are going to feed into this, and then it drives the constraints and any risk concerning sustainability. From this, we can define lifecycle concepts for our product, our engineered systems, and transform those into an integrated set of needs for engineered systems. And I'll go into more detail what that means. But from a product perspective, sustainability stakeholder real world expectations must be understood. Lifecycle concepts defined, sustainability capabilities identified, and communicated within this integrated set of needs. At the beginning of your project, our lifecycle concepts and needs definition. One is they're driven from our business and strategic operation level goals and objectives. And then during elicitation, in addition to use cases and user stories, we need to define misuse cases and loss scenarios from a perspective of sustainability. What misuse cases could impact our sustainability goals and objectives? What events, internal or external, could result in your sustainability goals and objectives not being met? And then what drivers, constraints, risk could impact your efforts to meet your sustainability goals and objectives. And then, as part of our lifecycle concepts analysis and maturation, we need to address needed capabilities to achieve our sustainability goals and objectives within identified drivers, constraints, and risk. And these capabilities are realized by addressing needs concerning the organization, the people, the processes, and the engineering system. We have three different paths here that comes out of our lifecycle concepts: our people and process needs, and also then our needs concerning our engineering systems. When I talk about the integrated set of needs, this is a big thing that's in the needs and requirements manual, that we don't think about just requirements. Before requirements comes lifecycle concepts and needs. And so the integrated set of needs represents an agreed to baseline scope of the project. It means that the customer has agreed with the needs dealing with sustainability and has agreed to provide the funding and resources necessary to realize those needs. So within the integrated set of needs, we need to establish the needs for sustainability. And then when the customer baselines this, they're committing the resources to meet those sustainability needs. So that drives all the requirements and design activities downstream. Customer acceptance then will be based on successful validation that needs have been met. And so when the system's delivered and they're doing system validation against the needs, they're also going to be checking the needs for sustainability, and acceptance of the system is based on those needs being met. Requirements are transformed to the needs via requirements analysis. Sustainability requirements must be defined, again, like I said, for people, process, and product. Each requirement will address the question, what must the people, process, and a product do to meet the intent of the needs for which they were transformed? The result would be one or more well-formed requirements that have the characteristics defined in the COSI Guide for Writing Requirements. And people and process sustainability requirements to be documented within their design controls. And I'll talk about design controls in a minute. And product sustainability requirements will be documented within the product design input requirements. So example need statements for the project team. So all these address those measures that I talked about before. From a needs standpoint, the stakeholders need the project team to do these different things associated with sustainability. And then for each of these needs, then they have to determine what role our people process going to have. How is that going to translate into requirements for my engineered system? And then I can define a set of needs for my engineering system, and I can transform those into a set of design input requirements to meet those needs. While valid stakeholder expectations, there's a lot of work that must be done to define well-formed sets of needs and requirements for both the system of interest and the organization producing that system of interest. These are things that we need to define up front, and then the project team has to do the analysis, develop lifecycle concept needs and requirements that address each of these organizational needs. I talk about processes, procedures, and work instructions. These are what we call design controls. They're part of a quality management system. When you look at the product, it goes through a series of transformation across the lifecycle. Each of those transformations is governed by organizational lifecycle concept needs definition requirements, requirement definition requirements, architecture and design definition requirements, system realization manufacturing requirements, and operations, maintenance, disposal requirements. And so from an organizational standpoint, sustainability needs to be included in each set of these requirements. And then from a product standpoint, those sustainability needs and requirements associated with the actual engineered system then are going to be addressed across the lifecycle, from expectations for sustainability, the need and capabilities for sustainability, the design input requirements that the system has to meet to achieve those needs, the design output specifications, architecture, parts, materials that are selected from a sustainability standpoint, supply chain, the manufacturing system. Making sustainability happen is a big challenge. So for both your organization and individual products, you need to have a clear mission statement, goals, and objectives from a sustainability perspective, environmental sustainability, sustainability enterprise, sustainability of the product through its life. List the sustainability measures you're going to use to measure progress toward your goals. List the drivers, constraints, and risks that may limit the ability to achieve those. Update your business and mission operations requirements for sustainability. Develop a sustainability standard for your organization. Develop lifecycle concept needs and design input requirements addressing sustainability for both your infrastructure as well as your products. When I say infrastructure, all your buildings should have sustainability standards like LEED standards and so on. And update your design controls to address sustainability. These are the requirements again on the people doing the system engineering. And across the life cycle, they need to always be keeping sustainability in mind. The last slide, practical considerations. As sustainable as reasonably practical is ASARP. So there's ideal sustainability goals and objectives for a system, may be aspirational, like the INCOSE Vision. The integrated set of needs must strike a balance between ideal and what is as sustainable as reasonably practical. So the needs validation process must ensure the collection of needs and statements are feasible and align with the ASARP principle, particularly in critical areas such as budget. Can sustainability needs be met within an available budget? Can the organization realize cost savings by adopting sustainability principles? We have a supply chain. Will the materials and parts to support sustainability be available when needed at affordable cost? And then system cost. How will meeting sustainability goals and objectives drive the selling price of our systems? Will the resulting systems be affordable for the customer? Will consumers be willing to pay extra for sustainability features of product versus similar products that are not as sustainable? And then we have to worry about regulation compliance. Is the developing organization and resulting product satisfy legal and sustainability standards defined by agencies like the EPA, OSHA, or equivalent regulatory agencies? That concludes the presentation. Again, I produced it as an overview to a general audience that may not be familiar with sustainability. So any questions?
Thank you very much. That was a great presentation. To the audience, do you have any questions?
I have a thought I'd like to share. I'm just going to be a bit provocative. So another way of thinking about sustainability or sustaining, that can also lead to stagnation. Should we not be thinking more about not just sustainability, but vitality and health? I'm sure this wasn't intended, but I think that there was a lot of focus on engineered products, and perhaps we could have thought a little bit more about engineered ecologies, ecosystems, organizations that are more vital. I mean, sometimes an organization actually needs to die and get out of the way in order for the greater whole to thrive. So those are just a few of the thoughts that came to my mind. I mean, I really love the presentation. There's loads of great stuff in there. So it would be great to have the slides. But maybe we could be thinking a little bit more broader.
I agree totally what you're saying. The purpose of this presentation was really engineered products. You could develop another presentation that has that broader focus that you're talking about.
Okay, thanks, Lou.
Thank you, Gary. Any other question? Yeah, Randy.
Yeah, that was a really excellent presentation. One thing that occurred to me, I think you took a very reductive approach, and this is very characteristic of the engineering process. But I'm wondering if a different approach might also be similarly productive in thinking about resemblances of the systems rather than breaking down components into how these components operate and integrate together. Because we do have examples of sustainable systems all around us. So asking the question how the engineered systems may be made to resemble sustainable systems might be an interesting question to explore from this sustainability perspective.
Oh, absolutely. I mentioned that when I was getting my degree in environmental management, one of the books that we read in the concepts was environmental ecology, the goal of no waste, and developing sustainable systems that maybe a combination of systems taken together result in zero waste. Actual examples of sustainable systems could be a goal of a working group is to get that out to everyone to give them examples, especially within the driver's constraints. There's so many drivers and constraints, either the political will or from a cost standpoint or whatever it is, taking those into consideration, how can you still develop a sustainable system?
Yeah, as you were talking, I think at one point you were almost talking about homeostasis and sort of thinking about the notion of sustainability as a homeostatic system. Thinking more broadly about that, the concepts of heterostasis or allostasis, those also could be ways of thinking about models or examples of sustainable systems that, it's not just like one element of control, like, like a thermostat. It may be multiple elements of control is not really the right word, but I think that's the word in common parlance.
Yeah, I agree. One thing that Gary said, I don't know if I got it right, but Gary has mentioned in systems that were not just static, but could grow or whatever. But if you look from an example of nature, the whole idea of a climax state where it reaches a place where the inputs and outputs are equal, I guess you're static at that point in time, but everything's working in a sustainable manner.
Right.
We seem to be driven by constant growth. Our businesses, if you're not showing an increase in sales, if you're not showing an increase in customer, if you're not showing an increase in something, you're a failure. But is growth unlimited? Is there no limits to growth? And so there's a mindset from a sustainability standpoint is what rate of growth can we actually sustain, especially given that our systems are open systems, high dependencies on external inputs, and also dependent upon our negative outputs, waste that we do from that, part of it. So it seems like it's in our DNA, business wise, to always be growing.
Yeah. Yeah. And there I think you veer into the question of what is growth. And again, looking towards existing sustainable systems, biological systems on Earth do reach this climate state. And I couldn't point to any particular studies, but after so many billions of years, it maybe reached the point of saturation to where we are now. But there is a way that these systems continue to grow. It's not like growing in like mass, it may be growing in complexity. So there are different dimensions of growth. That's another concept that we could maybe look into.
There was a question in the chat from Adele.
Yeah, just curious on those thoughts on the role of software on all the sustainability stuff, because most people are concerned that depending on the language you choose, it could be you need more energy to run because there are more cycles, interpreted languages versus native. So yeah, just general thoughts on sustainability on a software perspective, if you will.
That's why I brought up the data farm is the expected exponential growth of the power usage and water usage and environmental impacts of data centers is very concerning. When you do a search or a query of a large language model, how many of you consider what the energy was for the software to respond to your query? And we're using it more and more. Do we need to control that? Is it really sustainable, the direction we're going?
Yep, great point. I use LLMs like I use water, let's say very sparsely, very aware that don't waste it. I'm very careful when I type my queries and not iterate on bullshit, let's say. Just be very sparse. Thank you.
Yeah, I think it's also a very interesting point, like on software, like it's more tricky because you don't see the negative impact because it's not a tangible thing that you can see it directly in the physical world. And it's even like more challenging to really measure it because you need to track it back the physical systems, for example, the data centers and the energy usage and so on. But I think like as a general rule, like in software systems, if you have green energy, you are already in the good side to a very high percentage.
There was just a thing in the news, I think yesterday here, where Microsoft is planning on building their own nuclear reactor to power one of their data centers. They have these, what do they call them, micro nuclear reactors now? They're nuclear reactors, but they're a whole different technology. And they can be fairly small in size versus the old ones. They're saying that that nuclear reactor is what they need, and I guess that's not using carbon fuels. So is that a sustainable thing?
Yeah, that's also a good question. Kai had her hand up, and good that you joined us, and thanks for organizing the meeting.
No problem. Thank you, Lou. This was really interesting, and I'm really sorry I came halfway through that, so I didn't catch a lot of it. Also, I'm not an engineer, so I cannot speak to this really very engineering specific part of requirements definitions, I guess. But there were a couple of things that which struck me as what you said, and I wanted to sort of comment on them. And also a little bit on this software question, maybe. Number one, as Gary said, the vitality I think is really interesting. And you pointed out in your, from the bit I caught, also the importance of the organizations sort of buying into the sustainability at an organizational level. And I wanted to point to our upcoming session with respect to that as well, because it speaks, I think, to both of these points, how to really sort of use a strategy, I guess, a strategic sustainability as a strategic tool to onboard the entire organization. That's what the presentation by Capgemini will show us with the maturity index. And the second part is that they have a type of measurement which goes into the direction of what Gary pointed to. So it's very much linked to vitality, I think. And so I believe that we will have a couple of things moving forward, which will show us some of these elements or how they are interpreted. So for them, it's a very strong part in this maturity index where they look at health and well-being, as well as vitality, and it translates in their maturity index. And I don't have the term exactly, but already they use terms which are very close to the circulatory system, for instance. And I think that's an interesting point there. Another comment I wanted to make, and Tim Lenton, who agreed to also present to us, I'm sure will have more points also for us moving forward with respect to what has been addressed partially in your presentation, because he just published a paper on positive tipping points. And I think there are things which might be interesting with respect to that. The last thing I wanted to comment on, and maybe Randy, if you're still there, we can point to a session we did with respect to the software development paradigm, I think is what I would call it. And AI, I'm very glad to hear this fantastic way you put it, Adele, where you said using it sparsely like water. That's already really lovely to hear. I think that's fantastic. We had Bert de Vries from TU Delft, I think, present to us. He works with what else? Randy, help me out. What do we call the AI on Carl Friston's work?
Active inference.
Absolutely. Thank you. He was talking to us, and we have that presentation, and we might be able to point it out, where he points to a software development paradigm change, which would be necessary. And Alison showed that in the introduction. She uses it in the introduction to the Natural Systems Working Group as an example as well, where he shows what it would look like if we would use the amount of energy the brain uses, for instance. Priest explains in his works and in his talk as well, and especially if you can go on his Machine Learning Street talk video on YouTube, where he really describes what a software paradigm change would entail. And I think it's really interesting, because it says it might be easier really on the software side than for control engineers or control system engineers like you guys. So it's just a comment I wanted to offer, and a point maybe to look at a couple of sources we have in the Natural Systems Working Group and with the upcoming stuff, because I think it really becomes essential to move to these directions. Thank you, Lou. It was a fantastic presentation, and hopefully we get to the vitality there. Sorry.
Your first point, I think it's really critical to focus on getting the organization at the top. The strategic planning needs to address sustainability, and then action plans formed to implement that strategy throughout the organization, both for its own infrastructure as well as the products and services that it makes. What I was talking about for engineered systems isn't going to happen unless that higher level approach to sustainability hasn't been defined in part of the DNA of the organization. I think from your working group is first focusing on making that happen.
I think Alain had his hand.
Yeah, it was a very general question I asked about, as you mentioned, the growth and maybe vitality, but you came back to the growth wording. And I think in all our activities as companies or businesses, we have the implicit hypothesis that the society can have succeed in decoupling between the economic growth, at least making business and so on, and the sustainability. And by the way, I wonder if there should be sort of a qualitative change in how to work, in the requirements, in the needs, if this hypothesis doesn't confirm, because it's sort of a trust we have or we don't have. But if we don't have in your idea, should it be completely different, or should we add some things? Or it's a very general question. But do you have ideas about this coupling between the growth and sustainability? You said as sustainability as possible should be maybe more realistic, but can we do it?
That's a societal question. Right now, it seems like all of business is associated with growth. It seems like population growth might be leveling off due to some natural system constraints, but businesses right now, you get fired as a CEO if you don't show growth. That seems to be contrary to sustainability. But to sustain a company, it has to show growth. So now I have a contradiction in terms.
I share. Okay, but it should be a long discussion.
Randy.
I think that those are really great point. And to point out, going back to this notion of resemblances, natural systems, of course, do grow, but they grow to a limit. And that's what we call maturity. At that level of maturity, an organism becomes sustainable, again, within a limit. And we call that a life cycle. I kind of sense that this notion of resemblances are already creeping into the vocabulary of engineering. And I think going back to the conversation about AI and sort of the exponential growth right now of the energy use, we could maybe look at this as an analogy. It's like this is a sort of a first flush of a new organism, and we call them weeds, and they just massively proliferate and they use up all kinds of energy, but they don't last long. More mature forms come and take those over. They begin to use those energy resources. So I think, just thinking in the analogy of intelligence, the efficiency of these quote unquote AI systems is very low compared to natural forms of intelligence. It would not be very difficult, I think, to develop some sort of maturity index for, what do you want to call them? Intelligent systems, intelligent computational systems. A human or a dolphin brain, what's the conceptual limit? What do we know that's like the highest form of this kind of growth in complexity? I just wanted to kind of point that out, that there might be some useful tools there to think about the growth of these technologies, sustainable framework.
Have you read the report that came out called AI 2025? It's kind of scary, but they talk about non-organic alien intelligence and that it's being developed today. And there's cases where it's going to start replicating itself in multiple locations, multiple data farms. And then those replicated cells are self-learning. So they're going to start improving themselves to the point that they're actually alien super intelligent entities, and they keep reproducing themselves. That doesn't show any limits to growth. That's kind of a scary scenario. And without limitations and guardrails put up, what the report said is there's a really danger of that happening. But the other path is if we do put up guardrails and we do put up limitations, then we can prevent that from happening. Sadly, the United States policies went just the opposite. One comment I want to make on natural system growth. I had a chance when I was in the Air Force. I was a deputy commander of a Air Force installation in the Phoenix Island group. And we had one island there that had vegetation that had a population of rabbits. And the key thing is we always think of rabbits reproducing a lot. But on this island, the population of rabbits was stable. They self-regulated themselves to reach a climax state so that the ecosystem would support the number of rabbits that were there, and they didn't exceed that number of rabbits. And that was a natural system. Humans had nothing to do with it, but it actually happened.
Yeah, I think those kinds of progressions can be instructive. I would encourage pursuing that idea of looking at models that might be informative and instructive for engineering, not just like product systems, but also in this area of what intelligence, and what do we mean by that? Is alien super intelligence, like, yeah, that's a whole other conversation. But if we're going to facilitate that by plugging them in to the energy grid, that's on us. It's not on them unless you build that capability into that engineered system that it can plug itself in and create a new energy source or whatever. Of course, you could do that, but why? Of course, that conversation has to take place, yet it's sort of being left to market forces. So it's not happening in a vacuum. I think it's something that it would be advisable to study, the sustainability of that.
That report AI 2025 is based on basically a space race competition between the US and China. Who's going to lead the way in developing the alien superintelligence, and whoever is first wins. But by winning, we may have lost.
I think it boils down to who's smarter. I'm not sure the Chinese aren't. What does it mean to win?
So that report's really interesting. If you want a shortcut, YouTube has multiple videos summarizing that report.
Yeah, I've seen a number of years ago, I'm just kind of scratching something deep in my memory. There was somebody who did a paper on winner take all games, and it sounds like that sort of thing, but there are winner take all, and that's real, and there's winner that take all that is transitory. I don't know, what's the difference? And is that actually what you want? More questions than answers. And I think the point here is that sustainability is a key question for us to wrestle with.
Yeah. Thank you, Randy, for your points. Do we have any other questions? I actually do have one. As you mentioned, Lou, so traditionally, especially like systems engineers or engineers, we were focused on developing systems that functions as intended, and then we are focused on the economical benefits, and that's it. So now with sustainability, we need to consider the environment, we need to consider the societal perspective. And then we don't have any more a linear economy or a linear life cycle. We have a circular economy. So we have the reuse, repair, recycling, refurbish, and all these are strategies. Let's even add to that, there is also a shift from a resource and sustainable perspective to not sell products, but sell a service. So instead of selling car, provide driving as a service, and then by that you can build a car that has long life and can be used by many people and so on. And all these different perspectives are all requirements that are just added to the products or the business model or the enterprise, and all this level of complexity. And all these things, of course, they have to be smart, they need to be tracked so that it is maintained at the right moment. Maybe it will be also added some AI components into it. How do you see this evolution of complexity in requirements? Can we continue like this, or is it a sustainable way to continue like this?
There's a lot of challenges, but there's always going to be evolution of thoughts. Just like you say, instead of selling cars, we sell transportation. We've done the same in the music industry. One technology replaces another, but there are requirements. The thing that is most scary now is up to now, most of what we did was deterministic. And when we start adding non-deterministic AI systems, verification validation becomes problematic. And so we have to kind of deal with that. Related to that in software, we're accepting a whole lot from a black box perspective. Like a lot of the AI applications, even the developers aren't sure what's going on inside the box. So they get scary. And then from a security standpoint, it's even scarier. If you incorporate some component with software into your system and you have no idea what's going on inside that, you've kind of given up security. So the complexity adds challenges. And I think where system engineering really comes in is the idea that we're managing from a holistic standpoint. We're looking at the interactions, and we recognize that there are going to be emergent behaviors, and we're going to try to manage those emergent behaviors. But that's just a natural progression of technology. Things are just going to be more complex, and we're going to have to deal with them. One of the advantages of maybe a model-based approach, there's too much to keep track of in our brain. So in a modeling that environment, we can maybe manage those interactions a little bit better in a modeling environment. But
yeah, I mean, it's still somehow a big question mark for me. Can we really continue in this evolving complexity of technologies, or is there a simpler way of things?
I don't think things will get simpler. They're going to get more complex.
Yeah, things are getting more complex, but somehow nature is very simple, I think, in how it does things. I don't know. I still don't have any answer for that, so I was just like asking it. Do we still have any other questions?
Just to add an answer to the complexity that you mentioned, I wanted to add something that the requirements can help us to decrease this level of the systems complexity, this level of the growth of the complexity. If you go back to the concepts like defining the functional requirements that comes from the requirement writing and management, so then if we can define these functional requirements in a way that as much as possible independent, then in some way we can control the complexity that are growing during the system development in the systems engineering. So maybe on that way we cannot remove all of these requirements that are coming to us with sustainability, with adaptability, with resilience, with cybersecurity, or with safety and so on. But on the other hand, it's not something that we can control them, but we need also address. So in some way, I think if we go with the main step of the requirements, that where we will define the functional requirements, then we can in some way control this complexity by finding the interaction, finding the impacts on each other, positive, negative, and how we can control the level of the complexity of the system. It's actually something that I saw that one during my research, and I see that it totally would be helpful, especially in sustainability, because we are dealing with lots of topics from economic side, from social side, from the environmental side, from even governance side. So there are lots of interaction between them, and we need to control all of this. So in that case, if we go back to the first level of the requirements, defining the functional requirements, then would be helpful to manage them in a right way. And the other important thing that I saw in this conversation was about the plans of the companies to addressing this sustainability, if they have short-term plan or long-term plans. Like the examples that they said, for example, the CEO of the company need to show the progress within 3 years, 4 years. So for sure, they will go to select the short-term ideas to see in this 3-4 years, they can actually present some improvements to have, for example, maybe positive points in their CV by the end. But you can see that in sustainability, it's something that in some way we need long-term plans. At the same time, we need also have short-term plans, but they are interrelated. So in that case, maybe the CEO of the companies, when they need to consider their short-term responsibilities, but on the other hand, if they want to consider sustainability for the whole organization or a company, then they need to consider that as a long-term plan. So in some way, considering all of this interaction, I think it's totally important. So if they want to go in one of this direction in addressing the sustainability, they will lose the other direction. And one important thing is to have all of these metrics, all of these indicators that we have in sustainability from different point of view all together. Otherwise, I think is not something that we can say we can approach the main goal of the sustainability or realize the sustainability goals by the end. They have to be considered all simultaneously.
I think one of the big problems that we have is from a business standpoint, businesses for sustainability have to think long term. That's got to be in their DNA. The problem is that we have politics and we have governments, and they tend to think in the short term. Like, am I going to be able to stay in power if I do this or that? The people that are supporting me and funding me, they want this change made now, and they don't care about the impact of that downstream. So we're always fighting between the view from in a business enterprise versus a political enterprise. Politics tend to focus on short term. Businesses have to really think about long term.
Exactly. That one is the main challenge, especially to implementing the sustainability concepts or standards. So politics push in some way other rules, and then in the implementation they have other challenges. Which they will enforce organizations actually to make decisions that maybe could be good to addressing the sustainability for short term, but in the long term, so it's not actually a right answer. Like energy, for you will go toward the renewable energy, but then your infrastructure is not adapted to that new kind of energy. So they have to be in some way cover each other. Like on the other hand, going toward the nuclear energy, but companies right now, we can see that they are saying, okay, it means that now we have to bring exclusive things in the company. So it's something that no, we don't want to go toward that idea. So on the other hand, hydrogen powered, or the other sources maybe in some way is not available in some part of the countries. In that case, always there are different alternative solutions that we have to address in the sustainability, and considering each alternative, then the impact on the other side of the sustainability will come up. So maybe one alternative would be good in one criteria, two criteria, but on the other hand is not good. And if you go to another alternative, then it has positive impact on one side and negative impact on the other side. So always there is this kind of interaction between finding the best solution between lots of alternative solutions that you have.
Exactly. Yep.
Thank you for the presentation also.
Yeah, thank you, Lou. I think it's a good time to wrap up. Thank you very much, everyone, for being present with us and for your questions and discussion.